All right, good afternoon, everybody, and welcome back to Discrete Math. Plan for today is apparently I'm not giving you a joke.
That's Elaine and Abby.
And Nick.
And Nick.
And at least one other person, I forget.
Partially me.
They're not in here.
Hey, you.
My idea.
Yeah, blame Adam. Anyways, presentation on the graph theory packet, and then I have a follow-up packet for you looking at the difference between paths and walks and cycles and trees within a graph. Next office hours are on Monday at 11 and after class. As far as homework goes, yes, you do have a mistakes journal due Monday. No, you will not have one due the Monday after Thanksgiving. Actually, now I think about it, well, this will be your final mistakes journal entry. Last mistakes journal entry of the semester, due Monday. And then we'll do presentations on Monday on the new graph theory.
My biggest mistake was taking this course.
He's already having such a bad day. And like, if that can't, like people expect mean things from me, but you're like a nice person, so they'll like see you better.
It's not even going to be recorded. Look at that. I could be abused, and the camera could be running.
There we go.
Should be an exciting class.
Okay, I got you. You caught me in one of these bits. Something I was hoping to have for you for class today, but I just didn't get finished making it in time. Is kind of the instruction sheet for the final proof portfolio, kind of what the expectations are. I'll send it out this afternoon. I'll finish writing it up after class and send it out after class. But the gist of it is, no, it does not need to be typed, but you do need to make sure you've written up clean versions of all of your proofs, meaning no like extra markings or stuff. I want it to look, nice and neat. Give me a cover page with your name on it, just to make it look a little bit snazzier. Questions come up a couple times in office hours. No, you can't double dip, meaning if you prove some relations example some problem from the relations packet, let's say by contrapositive, you can't have that count for both the contrapositive proof and the relations proof. I want to see something separate for each. So the ones that say prove directly, prove by contrapositive, prove by contradiction, you can prove. Those can come from whatever packet you want. And on the instruction sheet, I'll explicitly say, like, these problems, when I say prove something from set theory, I mean prove something from one of these packets, explicitly. Yeah, I think that's the main gist of it. I just need to finish writing it up. I probably can send that out to you like 15 minutes after class today, honestly. But do you all have any questions for me right now? When's the proof portfolio due? I was going to leave it all up to you to decide. I'll give you two options. One, it's due at the same day as your final exam. Two, it's due the last day of class.
Final exam.
Yeah, final.
Make it due along with the final exam?
Yeah. What day is final? The final's due on Friday.
Friday. Man, that means I have to still wait till it's graded.
Well, again, you could just,
No. Okay. I'm gonna remove your agency of choice. Do Monday of finals week.
Okay. That's fair.
Give you a couple extra days to work on it, but not like.
So how would you like us to turn it in? Just like drop it off to your office or something, or?
Yeah, you could either put it in the mailbox outside my office door, or bring it the last day of class if you've done it by then. If you've typed it up, you're welcome to like email me, copy. Make sure I have it by the end of the day, Monday of finals week.
11:59 p.m.
11:59 p.m. and 59 seconds.
Okay, got it.
Is the final
Eastern
take
time.
home as well? Eastern Standard Time?
Yes, that's what. Yes.
Hour with the West.
Does it feel what?
That was just exciting news.
Your face for a second.
Because it's our final, it's like my last final, and it's on like Friday, I think, at 1, which is just like not an ideal time,
So yeah, your final exam. It's take-home final only, no in-class portion this time. Dr. Ursel, what about our take-home midterm? You're getting it back. You might even get it back Monday if you play your cards right.
We start receiving points back if we don't get it back at some point.
No. You can start losing points at some point if you keep heckling me about it.
Yourself.
I'm not taking any suggestions from you today after what you said.
My apologies.
Yeah, it'll be a take-home exam. I'll let you work on it with a partner, just like with the midterm take-home. If you want, maybe start shopping around for partners now. I'll even allow you to work with the same person if you want, or you can branch out more. You know, work with other people in the class. Expand your horizons. Be bold. Be brave.
Sounds scary. You felt.
What?
You felt. Stand strong.
Yeah.
He was glaring at me.
All right. Any other? Take-home final. I'll send it out sometime during your last week of class. So you'll have at least like a week to work on it. And then during finals week, I'll have some office hours scattered around, exact times to be determined, where you can come, and you're welcome to come ask me questions about it. But and it'll be due at the time of your final exam, 1 o'clock that Friday.
At the start of that exam at the end. So
At 1 o'clock p.m. that Friday.
Just like in your box.
In my mailbox, get it to me however you want. Just like with the proof portfolio. Any questions or comments about any of that? Proof portfolio, I'll be sending out instructions, like I said, after class today. I was hoping to have that done in class today, but I hope for a lot of things in my life that I don't get. Like more grateful students.
I'm sorry. I really do enjoy this course.
I'm just teasing.
I heavily do.
Okay, let's see. Presentations for today. Let's go with, all right. Isabel, you want to kick things off for us?
Of course.
I figured I'd skip the page that was just kind of mainly listing out vertices and edges from the cities, just because writing all those down would just be kind of tedious, and I'm pretty sure you all nailed that one. All right.
Alrighty, hello. So we have this graph in front of us, and the first question it asks is which vertex/vertices in this graph have the highest degree? And for this one, I said that the vertices with the highest degree were V2, V3, and V4. So if you look at the graph, each one of these has a degree of 3 because each one there are 3 edges that are incident to the vertex. So the degree of V2 is equal to the degree of V3 is equal to the degree of V4, which is equal to 3. Any questions so far? Alrighty, and then for the smallest degree, I said for this one that it was V5. If you look at the graph, this one only has 1 edge, so it has a degree of 1. Any questions? All right. Dr. Grosswell, I feel like you want to say something. Oh wait, I wasn't even done. Okay, my bad.
I was saying, you're not done yet.
I know, I literally didn't realize that. Okay, and then for does this graph contain a triangle? The answer is yes, it does, and it is formed by V2, V3, and V4. Where the set containing V2 and V3, and then the set containing V3 and V4, and then the set containing V4 and V2 are all questions? Yes.
This is not a completely thought out question, but it seems like there's something here that almost reminds me of the transitive property from relations. I have those with definition. Yeah. Do you think that's another way to think about this triangle? That they kind of come back to themselves in the same way that the transitive property does? Or do you think that's not really helpful?
No, yeah, I get what you're saying. So it's like if V2, like I guess you would say like if it, like V2 is related to V3 and then V3 is related to V4. So I guess it would be like if you're saying if X is related to Y, Y is related to Z, and Z is related to X. Essentially. So I feel like it's not entirely like the transitive property, but I see where you're coming from.
Okay. Yeah, I don't know where that came from.
Anything to add? Yes.
Okay, well, I had a different question I was going to ask, but now Griffin's giving me a new idea. If we were to define a relation where the set of objects is just the set of vertices in this graph, and our relation is X is related to Y if there exists an edge between X and Y, is that going to be a transitive relation for this graph?
No, I don't think so.
Why not?
Because you could have, like, I guess I'll look and find an example. So you could say V1 is related to V2, and then you could say V2 is related to V3, but V1 is not related to V3.
Interesting.
Anything else? All right.
Nice job. Yeah. So this is kind of a sneak peek for a couple packets from now when we start looking at more different special types of graphs, where you can, given any graph, you can always define a relation on the set of vertices by vertices A and B are related if there exists an edge between them, and depending on the graph you're looking at, whether the properties of that relation could tell you some interesting things about the shape of your graph. Okay, and with that, we have Laurie. He's going to prove number of edges, 2 times number of edges is the sum of all the degrees.
So I don't know if my proof is that good. So my base case is if E equals 1, there are 2 n vertices, meaning that they both have degree 1. So sum of the degrees E equals 2. And then my induction hypothesis is just assume for some K that the sum the degrees D equals 2K. And then the induction step is where you have to prove the K plus 1 case. So I said, then in the graph with K plus 1 edges, the sum of the degrees of the first K edges will be 2K. Wait, some of the degrees. And then the additional edge will have 2 vertices. So we'll add 2 degrees to the ground. And then the total number will be 2K plus the 2 extra vertices. And that's by induction. It must be the case that the sum of the degrees equals 2V. Should I write that?
Sure.
Does anyone have any questions? So,
So I have like degree of everything that you have except for in the third line you said that the sum of the degrees of the first K edges will be 2K. And that was just a little confusing to me because like wouldn't it be the degrees of the vertices, not the degrees of the edges?
oh yeah, I think so.
You're basically saying it should say something like the sum of the, if we have a graph with if we have a graph with K edges, or a graph of K plus 1 edges can just come from adding an edge to a graph of K edges, and the degree sum in the first graph will be 2K, so adding a new edge will give us 2K plus 2 to the degree sum of the vertices. Okay.
Wait, so this should be vertices?
Yeah, usually when you talk about the degree, you talk about the degree of a vertex, because the degree of an edge is, if we have degree of an edge, it would always just be 2. Because any edge is going to connect to, well, from everything you've seen so far, the degree of an edge would just be 2. Because we haven't talked about loops yet, they're just edges that connect a vertex to itself. But yeah, typically when we talk about the degree, we want to look at the degree of a vertex, not the degree of an edge. Yeah. Any other questions or comments for Laura? Okay, nice job. Yeah, I thought you did a really good job with your proof there.
I just felt like it wasn't that mathematical.
Well, like adding an edge will add 2 to the sum of the degrees.
I don't know.
Well, I'll
It
say
just didn't feel like a formula.
I'll say it was, what you had is very close to what I had. So yeah, no, I thought you definitely had. little bit of notation aside, I think you definitely had a strong idea there and did a good job with it. So, nice work. Okay, nice job. Okay, so for the next packet, we're going to be looking at what happens if we are given a graph like this. We're going to look at the question of, what if you're Adam hanging out at V1 one day and you decide to go for a stroll through the graph? So, and since you're a well-mannered, principled, law-abiding citizen like Adam, you're only going to walk on the edges and not try and cheat by like cutting across the graph, so to speak. So Adam, if you're at V1, where would you might want to go for your first step of your stroll?
Start heading towards V4.
Okay, so Adam's going to go to V4. Evan, where do you think would be a good place for Adam to go after going to V4?
V3.
Okay, see an edge there, so we can go to V3. Helen Mariah, how about V3?
V2.
And the V2? Okay. Laura, how about after V2?
Go back to V3.
Okay. Isabel?
Oh, I'm feeling V4.
Okay. Lily?
V3. Definitely. Back to V3.
Adam's being a bit indecisive in his stroll, that's okay.
I approve.
He's like, you know what? I just really love this stretch between like V2 to V3 to V4. I'm just going to go pace back and forth on there a little bit. All right. Let's say, Jacob, let's say Adam looks at his phone, decides, oh, it's almost time for dinner. I better start heading back home. Where would be a good spot for him to go from V3? And let's assume his home is at V1.
V4.
Okay. So we're going to go back to V4. And Holly, take it home from there.
V1.
Back to V1.
What's getting
I said
hungry?
V3.
So as you're gonna see in this packet, we would call this sort of thing. We would call this sort of going from vertex to vertex by following the edges. We are going to call a walk through the graph, where a walk is going to be you start at a vertex, you travel from one vertex to another using any combination of edges, and you may or may not end up back where you started. You may or may not use the same edge more than once. And looking at walks in a graph like this are going to tend to have some interesting properties to them. Yeah, it's going to be the main focus of today's packet, so with that, I will let you all go loose on that. What's that, Jake?
There's no path for this, is there?
Sure there is.
No.
Here, take 1, then 5, then 6, then 2, then 1, then 3, then 4, then 4 again, then 7.
Can't you say you can't cross?
Oh, for path. Oh, you said path. I thought you meant walk. There is no path. Well, there may or may not be a path, but there is a walk in that you can use the same bridge more than once.
Okay, yeah.
Just like in this walk, Adam tended to take the same edge several different times. At V3, V4. I don't know what's there, but something scenic.
Yeah.
I'm guessing.
Or maybe Dr. Bolasov wasn't driving around there, so she didn't almost hit me with her car. Did you ever hear about that?
Wait, what?
Dr. Bolasov almost hit me with her car while I was riding my bike on Parents' Weekend this semester.
Oh, gosh.
Yeah.
I'll have to ask her about that.
Yeah, that's really funny.
Maybe Dr. Bolasov's driving back and forth
Exactly.
between V1
Safe
and
over
V2.
there.
You're just trying to avoid this.
Exactly, I have to stay on V3, V4.
I guess that edge was never taken, so something to be careful about. Okay, how to divide up groups today? You know what? Boom. Let's go to this. Let's have Griffin, Holly, Sophie be a group. We will have Isabel, Laurie, Alex be a group. Raise your hand if you're not in a group. Suckers, you didn't sign up for anything today. Jacob, Helen, Mariah, Lily is a group. Adam and Laura, You can either form a group of two. Oh, and Evan. Sorry, I didn't even. Sorry, Evan. You're situated just so you like your head was right behind your hand, so I didn't even see your hand there. Okay, well, 3-viewer group. With that, go ahead and pass out the new packet. Have fun. All right, so 30 suggestions was, let's give the class some nature to look at.
Or just follow Alex.
I was just gonna say, or I could just follow Alex walking like perfectly paced with the camera there. Okay, have fun.
You just like
That is not a spot here.
what a great spot. Big fan.
Oh,
I love that
that's
spot.
right. Why are there so many
I know.
Don't you think that's
That's okay.
Who's up?
I don't think I have like flower lace contours that I bought at Ross. And I've never.
Before you look at what, so you're gonna look at subgraphs.
It's a subset.
So basically any sub-collection of vertices from your original set, where you include some, but maybe not all of the original vertices. Is it now?
I'm assuming not, but it just.
Okay.
Well, maybe the second question on page 2 will change your mind.
Of like other V and like other E. That means that G star has a subgraph.
I'll give you a hint. This one has the word all in
Yeah.
italics.
I was looking at it. Do you know how Alex, the set of all edges?
That's too artistic for me.
Tracing?
Yeah.
Well, the only other option is drawing it yourself, so. I feel like that applies more. Obviously.
I guess is the first one.
I always just took out A5 from stuff and I left it as a graph.
Yes.
Yeah, I closed the graph, but I don't think it has to be.
Wait, so.
Oh, wait. Draw the subgraph G star G
Set up all the different vertices.
Yeah.
But then in like the paragraph on here.
Basically, you take those vertices and then snip out any edges connected to that
So
aren't
do we have to
connected
add
to
one
two of those
to
vertices.
But how do you know
This is the same group, right?
Okay, vertex. So if I understand, you also have to
Yeah. Oh, a subgraph, not.
Yeah. Okay, find a subgraph G
Simply to create.
of G that is not a subgraph generated by.
And if it's whatever you want, so I guess.
So just any
What
other.
what is it about this? So that's what's
Wait, what's
So,
No, I think it means.
So basically here, you need to find a subgraph that's not just the subgraph generated by whatever set of vertices you
Well, this
use.
seems very.
okay.
So can we?
Proving that the subgraph generated by a set of vertices is not necessarily going to give you an arbitrary subgraph. Some subgraphs are generated by their sets of vertices, some are not. This script's looking at me funny, so I'm gonna come.
So can this have edges that you're going to
Can you just walk us through? That's what I'm gonna do. I think these
Yeah,
are
it's not for it doesn't
For the top
have
one there?
edges.
Yeah.
So when you take the subgraph generated by a set of
Because this one,
vertices,
like, I've
you're making a new graph
joined
whose
all of these.
only
right?
vertices are
So I guess
V1,
this one
V2, V4, and
could
V6.
have edges.
And the
Oh,
edges
yeah.
in your subgraph generated are going to be all edges from the original graph that happen to go between two of these 4 vertices. So like,
Because E star has to
since
be
there's an edge, for
something.
instance, from V1 to V2,
So the edges
and
that we
V1
use
and
all have
V2
to
are
be-
both vertices in
Okay.
the set V star,
the one
you would
with
include
it.
that edge in your new subgraph generated by that.
Can you just re-explain that?
A subgraph, can we have our?
Wait, what if you
That's just
got
like, if we remove
What?
five, we have a subgraph, but that's not the only subgraph.
I'm not like,
Correct.
I'm just like.
Yeah,
curious,
so like
what
in the
is
subgraph generated,
What-
you don't wanna have any
what this
dangling
question
edges that are
means.
connected to
We
vertices
just
that are
find
no
a
longer
different
there.
subgraph that's not the
So
subgraph
for
generated by
instance,
V star.
so for instance,
So like,
V4 is
The
intercept
subgraph generated by
V star,
V
but V5 is,
can only include
so you would just
edges
remove that edge
that
because
connect
it connects
pairs of
something
vertices.
in your V star set to something not in it.
Sub
So you
set
just snip it out.
vertices, right?
And the only thing we would keep
We
are
can only have
edges that go
edges that
between
connect
It is a
things that are
subgraph.
both in V star.
Four,
it's just not the
right,
subgraph.
and these are the three
It is a subgraph, it's just not the subgraph generated
that do
by
that.
V star.
So we can just.
But I think
No.
just any old
because-
subgraph, you
because
just have to have
subgraph,
edges that are incident with only
V star is a
vertices
subset.
in V star.
Because it doesn't, so the edges that we use have to
They
with
branch
all the edges in here.
What
Is this
is
a different
this?
V star? So then this.
Those are the
why
same
is it
V star.
like touching?
So we
It can have it's not the same.
It's not necessarily the same
I'll
V star
figure
in
it
this
out.
question,
Like, why do you say?
But,
I feel like.
but basically, in the second question there, I want you to find the subgraph of the original graph that's not equal to just the subgraph generated by any set of vertices.
Yeah, I was convinced.
So something you
That
might
could
do
work,
is,
yeah.
Yeah, because you have to say, I mean, it's a different set of V stars.
I'll let you think about that. Sorry, Laura, you want me to
Like,
explain?
what if I
So yeah, I do
This,
what if you just
no, because it's not generated by V star, because this is missing.
Ooh, so you don't have all the edges that this one does, but you have some collection of edges that are all still edges in the original graph?
Yeah, because like, we're still supposed to use the same V star, right?
Not necessarily, you can
This
use,
For this
use a different one, but I think that works, Laura, what you have.
Didn't use like.
It's not the subgraph,
Does that mean you can't?
it's not the subgraph generated by those four vertices, because if it was,
This would exist.
Because then technically everything in the subgraph would still consist edges that are.
Thanks, Rob.
It just won't have all the edges. That's just where it is. Do you have any thoughts, Alex?
what's your best guess, Tom?
Like, so that you could create a subgraph where you just like take out one of the edges, so like if you just use it
I'm not
before,
understanding.
you could have like this edge and this edge.
And then, and then there's the dangling vertex with no edges attached to it.
Well, I don't know what you do about that, but.
No, I think that's
Oh,
perfectly
is that
fine.
right?
I think so, just like, last packet, we had a dangling vertex of,
Okay.
Juno.
So would you still include, like you would still include before, you just wouldn't include that edge?
Sure, I think that would be a fine way to do it.
Wait, what if? Okay, I think.
You're not commenting.
So we can.
Normally you like always.
So we can.
I'm just gonna.
Yes, so basically, yeah.
Maybe I'm misunderstanding the question. So that
Still have some questions about something else?
Sorry, yeah.
No, it's okay.
I guess I'm just.
So
not-
a walk does not have to
Between the subgraph and the subgraph generated by
connect back to itself.
here, but not.
So the distinction is, if you take the subgraph generated by a set of vertices, then you need every single one of the edges going between two of those vertices and from the original graph. But in an arbitrary subgraph, you can remove edges that were present in the original graph, even if you still have in your subgraph both of the vertices that those edges connected originally.
We're using the same like X.
Okay.
But
That makes sense, that makes sense, thank you.
the original.
Wait, a graph?
So like,
I would be careful with that, let's say, because if you're gonna like not use an edge of ones, like you have to, if you X is.
Well, it's not supposed to be.
Oh, this is cycle, okay.
Oh, no. Wait, which problem are we looking at?
I was looking at, like, if you're gonna use
Oh,
the
yeah.
same one in number two, yeah, I did.
Oh, I'll just.
Okay, I was gonna say, yeah, you're.
So is this the
graph?
Either this is like graph.
Okay.
And then like that was like my little path.
No, because
Like as long as like
not
Sorry, there's a typo in the packet in question 2 on the 3rd page. No, 4th page. 4th page. Number 2, cross out the bit where it says and in which no vertex other than X appears multiple times. It should just say a graph and a walk in the graph that starts and ends at the same vertex, but isn't a cycle. That's all it's supposed to say. So remove most of the second line. Graph and a walk.
So this is that a cycle, it's still, so you're still like, I think they're always choosing a subset of the but you're not including all the edges that same So by removing this edge,
So a
it's no
walk
longer a subset, generated point,
can't.
And is there a way we
Which
write
is,
that?
what's the difference between English and Vertex other than? Well, this is just like. Other than that, it's
so
still
you
a
can
subgraph
use,
of this,
like,
because
if-
it's still.
I have the example over there where V1 is home, you can keep going from V3 to V4, I'm pretty sure, but it's still vertex other than like all of the vertices.
And it's still a subset, right? It's not of edges, it's just not like the complete.
Question, Paul?
subset
Yeah,
edges
so-
given vertices.
If it starts and ends the same vertex X, but no other vertex other than X, so like, say that's your V1 over there, you could keep going from V3 to V4 to V2, right? And that would be still considered, that would still be considered that, like, cycle closed.
So you could have that graph, for instance, V1, V2, V3, V4, V1 would be an example because you're starting, other than you're starting and ending point, you're not visiting any other
I read that
vertex.
completely backwards. I thought it was you couldn't go to V1 vertex, but it's the opposite way.
Yeah, because it has to, if it starts and ends at the same vertex, then
Yeah,
you have to be able to get there twice.
I read that backwards. Okay. Okay. Starts and ends in the same vertex, but isn't a cycle.
Oh, so that just means we have to you have to repeat. So yeah, so if we like went out
Yeah.
and then returned back. And then went out.
And do a subgraph of the coding part of Bridges graph.
So you figure it out.
What?
Graph whose shortest cycle
Yeah,
has
I think
length
so.
4. Longest cycle. Let's start with this. Longest cycle.
Wait, is that?
So does that mean that there are 2 different ways to get back?
Correct.
Oh, interesting, okay.
My guess is it's like a box with X.
So I would have a cycle of length 4.
Yeah. And then
So would that work?
you need
I did like 1, 2, 3, 4, but then you must do words. Oh, 5. Oh wait, I need that other one. I heard 6 and then
So yeah, oh, so we can have more. I don't know why I'm tied to 4 vertices. That might not help me.
If you have a cycle, if you only have 4 vertices, and you're going to have a hard time finding a cycle of length 7. If the cycle doesn't allow you to visit any vertices on the starting point more than once.
Mine is definitely not.
Man.
It looks weird.
I was going to say, yeah, mine Sophie looks closer to yours, I think. But Holly, I like it. Yours has some nice symmetry to it.
traded it not to that. I started my cribbing
walk and then I got. They have a box. It's like a
So what's your walk?
Yeah, that's not a bad
I'm working on that right now. I just was having too much fun.
Yeah, because
Have too much fun.
Oh, you're going dot to dot.
Oh, man. Nice.
yeah.
Okay, that makes sense.
What do you think the name?
I tilted my head.
Branches?
No.
Branches.
Look like something a tree might have.
Maybe
Well,
a branch
no, like,
also looks like that, like this.
It has branches.
Think
I
about-
think it has.
Think about it this way.
Yeah, that's
Tilt your head to the left.
visual.
Does it look like anything that you
There
might?
we go.
Okay, it looks more like a bush.
Roots.
Wait, so.
That's what
There's
it
no
looks
trunk.
Yeah.
I guess you could have like.
It looks like a root system.
Okay.
Or they also said roots. But I feel like the tree looks the
Hey,
same.
no eavesdropping.
I think it looks the same on both sides if you think about it. It has the branches.
It's not really because the branches go out more than the trees, they like the bigger ones.
As a typical of branches, the branches aren't all
Yes.
spreading out to a single
Now-
point. You
now
can have it come out
it
from different points on the trunk.
Now it has
It could be a bush.
a trunk and roots.
So you got like one big one in the middle and
Say what?
It has a trunk and roots now.
Hey, I don't think it's a,
It's still connected. It should be.
A path.
It's still connected.
Not a path, an
Yep.
edge.
I just need it to complete the
Wait.
image.
Hey, is next here at this point right
Yeah.
here?
You're using.
Okay, then yeah, that's gonna fit.
You do not need to prove the following here. Okay. Love It's a good day. G is a tree. G is connected. G is no cycles.
You don't have to prove it, any of these.
This
Yeah.
would really be not.
Following statements are equivalent.
But you might find this theorem helpful for, say, the proof portfolio problems at the end of the bracket.
Any one of these is true if all
Yeah.
No, this is the last topic listed.
Say what?
If we choose one, complete one of these proofs, then we're
This,
good.
a cycle means going
One of these?
get
One
back
of
to where
these
you
you mean?
started.
Yeah, one of those guys.
Oh, wait.
Yeah.
Well,
You have to do one of these.
It means
Gotta-
whatever.
At this, as of today's class, you now have the capability of finishing your proof portfolio. That being said, this is not the last graph theory packet. There will be more proof portfolio problems to choose from.
Maybe we should just end up doing it, and then if it's bad, I just
will you accept?
end up doing functions.
I don't think I'll be ready for it. Say, would you accept a proof portfolio?
I'm so stupid.
Because we only have 2 weeks left and I have 2 left.
I was gonna say, if you're done, you are welcome to turn it in at any point.
Well, there's some that it's more of the getting the feedback, which I should just go to office hours.
If you want to come to office hours, you can turn in something like, if you want to turn in a proof portfolio entry next Monday, I will allow it. They have that count for next week's proof portfolio entry, and then I'll let you turn in one the following week as well, although maybe that last week you might want to turn it in on Wednesday instead of Friday. That time for me to look at it and get it back to you.
Just to clarify, there should be 12, right, or 10?
I think it's 12. I think in the syllabus, there's a typo. I can't believe I would make a typo. In that every bullet point listed in the syllabus, you'll need one for it. Since there's 12 bullet points, you need 12 proof portfolio entries. Ignore the fact where it says 10. Was the original before I added a couple more and didn't recognize the time. Don't worry. In the instructions I'm sending out this afternoon, I will make it crystal.
Oh, yeah, definitely.
Y'all doing okay back here?
Should really get all those tree proofs this weekend. Much of a draft on paper due.
I should get you more questions in this packet.
Well, you said you Oh, I mean, it's almost the end of class, so like, it's good timing in that way.
No, it's not. We still have like 5 minutes left.
Oh, I guess my watch is wrong.
Well, the clocks here, like, we started a little bit late, like, just because the clocks in this building are like a minute or two behind.
clock, how are you
I didn't know, I've never noticed that.
If I compare what the time the clock says to what time the computer tells me it is, I'm always starting class at like 1:01, 1:02, even if it says 1 o'clock.
I always go off the time on the computer, so
Well, good for you.
mainly because I can't see the clock in my abstract algebra class.
That's it.
Yeah.
What room is abstract algebra?
113. I said like the back left corner.
Well, then yeah.
Like,
You'd be able to, would you?
It just came into my head. I know, it's kind of.
Wait. This is.
Once you're giving me a slide, you're in. So-
Wait, do you know what I'm talking about?
Yeah. 2 seems easier.
No, it's like.
Either way,
Talks about.
it looks like
I don't know.
That's okay. I frequently.
I mean, it looks like the way we were told to draw a tree
Oh.
in grade art class.
I didn't know that was, I didn't know you
Draw
were
a trunk and you draw it.
I didn't have to touch, so I'm not
Like a
that.
tree.
Oh, wow. My
I'm
nails.
like, I just think it's making
No, it absolutely is. I don't have TikTok anymore either.
What'd you say?
It's a real virtue signaling going on right
Virtue signaling? I just said I would waste my time.
I really don't have TikTok.
I don't think that, I mean, maybe because people have more self-control than I did. It's a little ugly. I never drawn mine, but.
I feel, yeah, no, I kind of.
says.
Like,
What-
some
what's
people are
that?
like, oh, like, I got rid of my social media because I was productive into life or whatever. And I'm like, honestly, like, I feel like.
Ruth is the one I'm going for. But I guess, but I can kind of see the others as well.
Like, that's why I delete Snapchat.
Christmas tree cannot really
Like, of all the social
Yeah,
media,
sometimes,
Snapchat
like,
is
you
the
get-
most boring.
You get addicted, but then if you go
Oh
away from it.
yeah, I had like
Yeah.
80 snaps like every single day.
Absolutely.
And I was like, I don't want to give about it, so then I deleted it. I got like
I mean, there's plenty of
probably
projects to drop.
lost. I was like,
That's what I'm planning on
yes,
doing.
I'm fine. Yeah, just trying to find some land.
You have a lot more things that I can like know about.
Go off side of the road, small chainsaw.
I don't know if I can do that. I feel really
More
awkward.
fun with the chainsaw.
I know.
Dr. Bristol, do you like fake or real Christmas trees?
For cleaning up after fake, for general ambiance, real.
Absolutely, the smell.
Mhm.
Just get the cardboard.
No.
Real trees are nice.
Like a car freshener ornament.
You should get a Christmas tree for Dow.
That doesn't match.
That would be cool.
Ooh. My
Probably
mom's
not.
like the road up.
I'm putting you in charge of this project, Adam.
Okay.
Make it happen.
There's not a good space for it. The bathrooms are like the biggest rooms.
No, it's kind of awkward. It's like put it in the middle of the hallway or, you know, put it in a classroom or something.
Yeah,
Yeah.
I don't have any ornaments. I have some janky Christmas lights I taped.
Put it in 110B. That's a good spot.
Is that space in between like
Actually super smart.
Yeah, no,
Because like you don't get to walk around.
Not if you're on the
However, we have like this big.
there, that crawling.
Okay.
So, I mean, I wouldn't say.
I have a question, so like.
What about like,
We had
So just like.
what we call winter wonder weeks, which
About
was
Cypher's
every day at
office,
lunch.
he's the guy.
So there was like an overall year they get.
Okay.
Avery's office.
And you're like kind of getting points.
Well,
and
good work, team.
I mean,
Word.
yeah, Pat, yeah, because the Pat
My
doesn't
class
have to be a
was
single
every
day.
single year one decorating contest. Like I don't know, it was just like we weren't really we weren't allowed.
Actually, let me end class first and I'll answer this. All right, can I have everybody's attention? So we're about out of time for today. We'll come back on Monday, we'll talk about this, and then start talking about, on our next packet, we'll be looking at, given a graph, does there exist cycles from a point to another, from a point that happens to pass through other points? Does there exist a cycle that happens to pass through every point on the graph? Questions related to bridges of Königsberg, we will start exploring in the next packet. And with that, hope you all have a good weekend. See y'all on Monday. Yes.
How would you feel about a Christmas tree in Dr. Gable's office?